Today we're talking about complex numbers. Section 544. The goal will be to solve quadratic equations with complex solutions and perform operations with complex numbers. I need you to add something in on your notes. I need you to put in the words DEF with an underline, because this is a definition. Definition of an imaginary number is that I is equal to -1, or this I is representing an imaginary number. It's like the imaginary number. Square root of -9 can be broken up into square root of -1 times 9, which can also be broken up into square root of -1 times the square root of 9. And now we're going to learn how this square root of -1 can actually become I. And wait, square root of 9 we know is 3. But to write this in better form, we actually write this letter, this variable, which represents square root of -1, we write the variable last. So the 3 becomes a coefficient, I becomes after it, which can be broken up into -1 times square root of 121. So we're learning this definition, how if we can take square root of -1, that becomes an I, and then we can rationalize that other piece the way we typically would. Sometimes it'll be perfect, sometimes it won't. And we'll have to rationalize, and I'll show you how to write that later. So I squared can be broken up into I times I, which is square root of -1 times the square root of -1. So hold on real fast. Square root of -1, quantity squared, these operations undo each other, and we're left with -1. So where are these going to pop up kind of next week is whenever we start to solve. When we start to solve, we're going to get square root methods that, wait a second, we'll actually get square roots of negative numbers. We're going to be given situations where sometimes we might have a square root of a negative number. And what happens? Well, we'll show you. So this turns into x equals plus or minus square root of -1 times 16, turning into plus or minus square root of -1 times the square root of 16, turning into plus or minus, here we go with that I, times 4, but that's not how we write it. The variable will go last, 4I. Plus or minus 4I is the solution. So y squared equals -8.
Does it always have to be a lowercase I?
Always has to be a lowercase I. So I'm going to have times 2 times the square root of 2. So plus or minus 2I times the square root of 2. Next examples you don't have written on your paper. Let's see if we can do them. Number 3, r squared minus 4 equals -8. I got a feeling if we messed up somewhere, it would be at this step. That would probably be the only one. Whenever you add 4 to both sides, that right side becomes -4. So then when we take the square root on both sides, we get plus or minus square root of -1 times 4. Let me back it up. Or -4, if we need that, equals plus or minus square root of 1 times the square root of 4. We should get an I plus or minus 2I. Divide by -2. So I'd have 3 from that pair, I, times the square root of 3 from that one left over. So in this example, when we are adding two sets of complex numbers, we're going to add together the real part, 5 and 7, give us 12. And then the imaginary part, just like terms. In the next example, yeah, -6 plus 5 gives me a -1. Positive 3i plus another I gives us positive 4i. Next one. I'm only distributing that -1 out in front of that parentheses. And then getting like terms together, negative 5 plus 7i. This is in technical complex number form where you put your real part first and your imaginary part second. On the test, let's say you do 7i minus 5. I'm not going to freak out on you. But I'm letting you know this is the correct language form. Negative 5 plus 7i. Example 10 alone, we won't do 11 or 12. We get an answer of 6 minus 2i. When I distribute, it's going to look like the following. This turns into negative 10i. This last one turns into minus 2i squared. But hold on, wait a second. I squared, we learned, turns into negative 1. So this becomes negative 10i minus 2 times negative 1. So we get negative 10i plus 2, but to be technical, it'd be 2 minus 10i. This is how vectors are written, where you have the real part and then the imaginary part.